Hey everyone, and welcome to This Explainer. Go ahead and open up those engineering notebooks, grab a warm cup of coffee, and let's sketch out a really reliable, practical framework for starting software projects. You know, if you've ever felt completely overwhelmed by the sheer number of ways to kick off a new tool or app, you are absolutely in the right place. Today, we're cutting through all that noise to find some real clarity.
Okay, picture this. You've just joined a new team, right? The product idea is incredibly exciting, but the room is totally divided. You've got one person furiously sketching out a Figma prototype, another engineer is pounding the table demanding a proof of concept, and someone in the back is arguing for a tracer bullet. So, who's actually right? Well, the surprising answer is maybe all of them. But they're having the completely wrong conversation.
This is where we need a total mental shift. We have to stop fighting over our favorite tools and start identifying our actual risks. Arguing over which technique to use is a massive trap. Professional engineers, they don't choose techniques just because they're trendy or familiar. They choose them because each technique answers a distinct, specific engineering question. To find the right tool, we have to flip the script and ask, what uncertainty should we reduce first?
So, here's our game plan for today. 1. The wrong engineering question. 2. The uncertainty decision tree. 3. Applying the framework. 4. Avoiding common mistakes. And 5. The continuous engineering loop.
All right, diving right into part 1, reframing the project debates.
So here's the crucial point. Before you write a single line of code, you absolutely must ask yourself this foundational question. What is most likely to cause this project to fail? Seriously, if you don't know what might kill your project, you can't possibly know how to save it. Identifying this specific failure point is mandatory. It is step 1 of any robust engineering process.
Which brings us to section 2, mapping out those engineering risks with our uncertainty decision tree.
Imagine you are standing right in front of a massive branching decision tree. The path you take depends entirely on which of these 3 uncertainties is your biggest threat. Think about it. Almost every single project failure traces back to one of these 3 things. Either you don't know what the user wants, you don't know if the core tech actually works, or you just don't know if all these complex pieces can be stitched together. Once you figure out which of those 3 is your biggest immediate threat, picking the right technique is a breeze.
Let's move straight to section 3 and actually walk these branches using a real-world example.
Let's say you take the user uncertainty branch. A prototype is going to be your first destination. Say you're building an AI travel planner, but you aren't actually sure if travelers will even understand your complex new interface. A prototype is absolutely perfect here. We're talking a Figma design, a clickable demo, or honestly, just literal paper sketches on your desk.
Because at this stage, the AI, it doesn't matter yet. We are only asking if people can understand the interface. If they can't figure out how to search a destination or complete a booking naturally, it doesn't matter how brilliant your back-end AI model is. The goal right now is not engineering. The goal is purely learning about human behavior.
Okay, so let's say users love the design. Awesome. Now the uncertainty shifts over to the technology, which means we trace our finger down a brand new branch to the proof of concept. The interface isn't the biggest risk anymore. Now your biggest question is, can our AI actually generate a useful travel itinerary? This is no longer a design problem, folks. It's a hard technology problem.
Look closely at what we're testing here, or rather, what we're not testing. We are isolating just this one pipeline to answer a single engineering question. Can this tech actually work? There is no website, no login screen, no database. You are literally just feeding a prompt into Claude or whatever AI you're using and checking the generated itinerary. It's one small, highly focused technical experiment to prove feasibility. Boom! The AI works. Now we shift branches again to tracer bullet development, because our new biggest risk is whether all these moving pieces can play nicely together. We know the interface works. We know the AI works in isolation. But can everything talk to each other without breaking? Instead of testing a single piece of tech, a tracer bullet tests the entire workflow.
This is where you validate the whole end-to-end journey. The data starts with the user request, passes through the AI, hits external APIs for weather and hotels, gets saved to a database, and finally displays the trip back to the user. Sure, it might be a little ugly and is probably missing advanced features, but the data successfully fires through the entire system from end to end. It illuminates the path, quite literally like a tracer bullet in the dark, giving you total engineering confidence.
Let's try one more example real quick, an AI expense tracker. We followed the exact same logical progression across the decision tree branches. First, do users know how to upload a receipt? Build a prototype to find out.
Next, can our optical character recognition actually read crumpled up receipts accurately? Build a PoC to test just the OCR. Finally, can the uploaded receipt pass through the OCR into the database and actually show up on the financial dashboard? Build a tracer bullet. Notice how methodical that is? Every step just removes another layer of uncertainty.
Moving into Section 4, Dead Ends on the Decision Tree, or how to avoid some really common mistakes.
This is exactly what happens when you grab the wrong tool for the job. You hit a dead end. Look, building a stunning Figma prototype is a complete waste of time if the core tech you're relying on doesn't even exist yet. On the flip side, spending weeks coding a brilliant proof of concept for a back-end system is totally useless if users don't even want the product. And jumping straight into a tracer bullet before your core tech is proven, that just guarantees you're building really expensive infrastructure on a foundation of sand.
Oh, and here's a massive trap teams fall into: trying to do everything all at once. This entirely defeats the purpose of targeted validation. When a team splits up to simultaneously build a prototype, a PoC, and a tracer bullet, they are just burning resources trying to answer questions they shouldn't even be asking yet. You gotta let the biggest current uncertainty dictate your one single next step.
Finally, Section 5, letting evidence lead the way in our continuous engineering loop.
You see, this isn't just a straight line, it's a loop. Every step removes a risk and points you right to the next logical question. As your project evolves, your biggest uncertainty naturally changes. You identify a risk, pick your tool, like a PoC or a prototype, collect your evidence, and squash that uncertainty. And then, you take a step back, look at the project, and ask, okay, what is the new biggest monster that could cause us to fail? And the loop begins again.
I absolutely love this takeaway. Professional engineering is all about letting real-world evidence determine your next step. You aren't blindly following a rigid feature list or some arbitrary roadmap a manager made up 6 months ago. You are letting the actual proven reality of the project guide your decisions. The better you get at identifying exactly what you don't know, the better your engineering is gonna be.
So here's your golden rule. Identify the uncertainty first, and you'll find that the correct technique practically chooses itself. When you admit you've got a tech risk, the proof of concept just naturally raises its hand. When you admit you've got an integration risk, the tracer bullet steps right up. You never, ever have to force it.
All right, I'm going to leave you with a thought to chew on as we close up our notebooks and get back to work. Step away from your IDE, step away from Figma, and take a hard, honest look at the project you're building right now. What is the one thing most likely to make it fail? Find that uncertainty, and I promise you, you'll know exactly what to build next.